We can now take a look at the definition of a couple. In this case, we'll take a 50-pound force and we will imagine it being applied to a rigid body. And on this rigid body, there's a point A about which we'd like to calculate the moment. So in this case, the 50-pound force has a moment arm of 5 feet, meaning that the perpendicular distance from the line of action of the force to the point of rotation A is 5 feet. And we find out that we have a total moment about point A of 250 foot-pounds. And again, we recognize our designation of a counterclockwise rotation as being positive. Now the sum of the forces in the x direction for this force system is 0, and the sum of the forces in the y direction for this force system being applied to the rigid body is non-zero, it's 50 pounds. Now if we were to add a second force vector, again having an equal magnitude of 50 pounds, with a line of action that's passing through point A, we will find out that the moment about point A is unaffected because the line of action of this second force passes through point A. Again, the total sum of the forces in the x direction is 0, but in this case the two forces add in the y direction to give a total y component of the force is equal to 100 pounds. Now, if we took this force and rotated it 90 degrees, again allowed it to pass through point A and maintain its magnitude of 50 pounds, we would again find out that the sum of the moments about point A due to this two-force system is again 250 foot-pounds, because this force still has a line of action that points through point A. The sum of the forces in the x direction now, due to the contribution of this second force, is negative 50 pounds, and the sum of the forces in the y direction is 50 pounds. So again, essentially what we would consider an unbalanced force system acting on the rigid body. Now we can take this 50-pound force, again rotate it 90 degrees, again allow it to pass through point A, and now we have two forces that are equal and opposite to each other with parallel lines of action, with the total distance through them being 5 feet. In this case, the moment about point A remains 250 foot-pounds, because again we are calculating the force about point A, the moment about point A, and this second 50-pound force again passes through point A. But in this case, the sum of the forces in the x direction and the sum of the forces in the y direction equals 0. So this force system, composed of two equal and opposite forces with parallel lines of action, produce what we would refer to as a pure moment. And what we're going to do is refer to a system of forces like this as being a couple. So we typically think of these types of force systems as being applied to a rigid body, and we will call that set of forces a couple. Now, we've shown here that the couple, when applied to a rigid body, produces pure rotation and has no effect on the sum of the forces in the x or the y direction. So we'll disregard those for a few seconds here. And let's consider what happens when we take the moment of these two forces about some other point on the rigid body, say point C. In this case, the 50-pound force acting at a distance of 3, this one here, causes counterclockwise rotation of 50 times 3, and this 50-pound force has a moment arm of 2 feet, and again it's producing counterclockwise rotation to give me a total moment of 250 foot-pounds. So the moment of this force system, when calculated about point A, is 250 foot-pounds, and again when we look at the total moment produced by this couple system about point C, it's again 250 foot-pounds. Now we could say, is this a coincidence? Well, let's take a look at another point. So let's look at point D, and in this particular case we now take the 50-pound force here, which is at a moment arm of 2, but in this case it's causing clockwise rotation, so it becomes a negative 50 pounds times 2 feet, and now the total moment, or the moment arm between this point D and this force, has a moment arm of 7 feet, so it's 50 times 7, And when we add these two together, we again find out that the total moment produced by this couple system is 250 foot-pounds. So from this, we can conclude that the couple, the force system that we refer to as a couple, produces a couple moment. And the couple moment is not dependent upon a specific point, but is rather only dependent upon the magnitude of the force vector. Remember, the force vectors have to have equal magnitude, so I'll say the magnitude of the force vector times the perpendicular distance between their lines of action of the force pair. And since there isn't a point, there isn't a dependence on any particular point, we don't put a subscript here. So we just say that the total moment produced by this couple is the magnitude of the force times the perpendicular distance, which in this case is 250 foot-pounds.